right, Year 12 mathematicians, trigonometry is one of the biggest sections of A-level maths. So getting those skills right from the start is massive. So we're going to have a look at some of the basic trig equations and how we go about finding our multiple solutions within a certain range. So we're going to solve all three of these for 0 to 360. So we've got a cos equation, a tan equation, and a sine equation, so we get a chance to practice each of those skills. So cos x equals 0.3 is already in the form we need it so that we can type something into our calculator, okay? Remember, if we have a number in front, so if I had something like 2 cos x equals 0.3, it's not ready to type into my calculator. I would have to then do some rearranging, in this case, divide by 2, okay? But without that 2 there, we have cos x equals 0.3, so we go straight into our calculator and we do inverse cos of 0.3. So we can say inverse cos of 0.3, and that gets us a solution from our calculator of 72.54. Okay? Now the problem is that there are more solutions for our equation between 0 and 360, but our calculator is not going to tell us those. So we need to go and find them. So we're going to sketch ourselves a cos graph. Starts at 1, down, and then back up. Looks pretty good, to be fair. So it starts at 1 there. We've got 180 in the middle. We've got 0 at the end, and then 360 at this end here. So on that graph, we can mark on our 0.3 on our vertical axis here. So 0.3, put it somewhere around there. If we trace that across to our curve and down, that's the 72.54. Okay, so here is the 72.54. So we know that solution. We're looking for the other one. So if we trace that line across to where it meets our curve for a second time, we would like to find that solution. So the idea of the sketch is we're trying to spot where the symmetry of our cos graph is and how we can then use that and the 72.54 to find our next solution. So if I have a look, it's symmetrical straight down the middle here, this 180, it's reflected here. So if I know that this gap from the end at 0 to 72.54 where my solution is, I know that gap, then this gap here from the 360 to where this solution is must be the same. So to find this missing value, I'm going to do 360 minus 72.54. Okay, so I can do that on my calculator if I need to. So I get 287.46. And that's my second solution. So I go and add it to my list. So I add 287.46, and that's it. Right, there are no more solutions between 0 and 360. If I was looking for those, I'd have to move along to the next cos graph, which would then go past the 360 degrees I have here. All right, so there we go. First equation solved. Next one, tan x equals 2. Again, is in the correct form to type it into my calculator straight away. So I can go to my calculator and do inverse tan of 2 and find out what that value would be. So we have x equals inverse tan of 2. From our calculator, we get 63.43. So that's our first solution. So to find our next one, sketch ourselves a tan graph. Now tan's the weird one because it's got those asymptotes. So we might have drawing our asymptotes first. So there's one at 90. And our next one is at 270 degrees. So we're going to add that in. Then we try and draw our weird tan shape. So it starts at 0 and goes off up to positive infinity without ever actually touching or crossing the asymptote. Then we jump to the other side and we come up from minus infinity through 180 and up that way. So this would be my 180 here in the middle. And then I'd have the next part again coming back up here until I get to 360. So it looks something like that. So again, I can mark the 2 on my graph and say, well, 2, let's put it somewhere around here, across and down. That is 63.43 degrees. We found that solution, calculator gave it to us. So we're going to trace it across to find where our next one would be, which would be over here. And we're trying to work out what that value would be. So tan graph repeats itself. It repeats itself every 180 degrees. So if I copy this branch here and move it all across 180 degrees, I get the exact same thing. So any solutions I have just need to move 180 degrees further along. So I take my first value of 63.43 and I add 180 degrees. Okay, it gets me 243.43. If I tried to add another 180, I would go past my 360 degrees, so I'm not going to do that one. So I've got my next value, 243.43 degrees. Those are my two solutions for a tan graph, tan equation. So what you'll often find is once you're happy with that, most students don't actually draw the tan graph because they remember it's the easy one and you just keep adding 180 as many times as you need to. Okay? So our last one, sin x equals minus 0.2. So again, it's in the correct form already to type into our calculator. So we can do x equals inverse sine of minus 0.2. So in this case, we then go to our calculator and find out what that is. So inverse sine minus 0.2 gets us minus 11.54. So we have solution number 1, minus 11.54 degrees. Now, you might have already noticed that value is outside of the range of 0 to 360, but we still need it. Okay, so we have to keep it for now, and then we'll reject it later on. So we're going to draw ourselves a sine graph, check what that looks like. So it starts at 0, up, back through, that's going to be 180 there, and then down and back. Now, for this one, because I can see I've got my minus 11.54, a negative angle, I'm going to extend it back this way. Now, I don't have to do a whole wave. I can just do a bit of one, but I can need to do enough to kind of see what's going on. All right? So now I can mark on minus 0.2. Well, I mean, I can add my 0 there, 180 in the middle there, and then 360 on the end there. So if I add on the minus 0.2 onto my y-axis, so that's going to be around here, minus 0.2. If I go across and up, that is minus 11.54 degrees that our calculator told us. So we need to try and find the ones that are on this side, between 0 and 360, because that's the range we were given at the start of our question. So we're going to trace this all the way across until it meets our curve 2 times. So we need to go all the way. So there's 1, there's 2. So we have to then look at the minus 11.54 and how we're going to use that to find those other values. Okay? So the idea is hopefully it's just jumping off the page at us. We say, well, this 180 here, surely I've gone 11.54 further along. So I'm just going to do 180 add 11.54. Okay? Now what I'm doing there, and what you might find you do in other sine equations, is I'm doing 180 minus the first value I found. It's just that that value is negative. So if I do minus minus, obviously it makes it positive. So I've got 180 plus 11.54 gets me 191.54 degrees. Then if I look at my next solution all the way over here, I can see it's going to be 360 minus 11.54. So 360 minus 11.54, check that one, gets me 348.46. And those are my two solutions. So I'm going to add those to my list that I've written over here. So minus 11.54, I'm going to add 191.54. I'm going to add 348.46. And then when I check versus the range from 0 to 360 back at the start, I can see we already identified it, but now this minus 11.54, we used it to find the other two, but it's not actually one of our valid solutions. So we're going to reject that one. So I only have 191.54 degrees and 348.46 degrees. And those are the two values. Okay, so there we've got one each, one cos, one tan, one sine, and our method for solving and finding all of the solutions. So absolute core skills, we need to practice those, make sure they are absolutely perfect. So then when we move on to our more difficult trigonometry, that bit's easy. All right, awesome stuff. Hit that like and subscribe for more maths content from us.